first job, as always, could you just pause the video and have a go at the 4 warm-up questions? Okay, so let's have a look at question 1a. We're asked to solve this inequality. It's a linear inequality. You've done lots and lots of these. So just looking at it, there's lots of ways I could attempt this. I think the first thing we're going to do is just add 3x to both sides of the inequality. So I'm just making a note of what I'm going to do. And obviously, if we do that, you're balancing the inequality. The actual inequality is not changing. But now on the left-hand side, we have 1 only. And we have 3x subtract 5 on the other side. Okay, I can now add 5 to both sides of my inequality now. So plus 5. I want to get the x terms isolated. I'll just move up here to finish that off. So we now have 6 on the left-hand side is strictly greater than 3x. And now all I have to do is divide by 3. So x is anything strictly less than 2. With these, they did cause a little bit of a problem in year 1. So the first thing to do is to get all the variables, all the terms on one side. So I'm going to subtract 3x and I'm going to add 2 to both sides. Okay, that will get everything onto one side. Now if we do that, of course, we're going to have x squared subtract 2x subtract 3 is strictly less than 0. Okay, so we have a quadratic inequality. Let's check for a factorization here. Okay, well, it looks good. It looks like it will factorize. So we have x subtract 3, x add 1, which is strictly less than 0. And what I'm going to do now, I'm just going to jot down the solutions this if it was an equation. So in other words, the roots of the equation. So the roots would be at 3 and minus 1. Now, this is where we have to be careful. We don't want to just write down a false answer by saying, okay, x would be strictly less than 3 or x would be strictly less than negative 1. That's clearly not what's going to happen. We need to sketch the curve. It doesn't have to be an amazing sketch, just let's get the shape of it right. We have a positive x squared here, okay, which we can see. This is a positive coefficient, which tells me the graph is U-shaped. So I'm going to sketch the U-shaped graph, and I'm going to put the x-axis going through it. So you don't need a y-intercept or anything like that. And then we label our roots where the graph crosses the x-axis. So this is what the quadratic graph would look like for the expression on the left-hand side. Now we have to identify the region where this graph is strictly less than 0, which is what it's given here. Now, in other words, if you imagine this is called y equals x squared subtract 2x, let's just write that down. Y equals x squared subtract 2x subtract 3. Now, if we just make a substitution here, if that's the case, we're interested in when y is strictly less than 0. Okay? Now, that would happen when the graph dips below the x-axis. So let's just highlight that region. It's going to be all of this. And we just write down our inequality. So it appears as a set of solutions. So all the values between negative 1 and 3 will satisfy this inequality. Again, if you want to check your answers, just substitute in values that lie within or outside of that inequality and check that they do indeed work. All right, now moving on to question 2. the eagle-eyed among you will notice that we've actually solved both of these inequalities here, which is good news. So I'm just going to jot down the solutions again. I'll write it the other way around. So x is strictly less than 2. And for this region, x is between, or can be anywhere between -1 and 3, which will satisfy that inequality, the quadratic inequality. So now we need to find a set of values for x that satisfy both conditions. It says and, it has to satisfy both simultaneously. Now, the nicest way to do this is to draw a little diagram. So we draw an inequality graph. Okay, so I'm just going to draw, so this is going to represent the x-axis. Now, if we look at the inequality on the left-hand side here, I'll just mark on 0 as the origin. I'll put 2 on as well here. Okay, so the first graph is going to be anything less than 2. So all these values are valid. Okay, I will highlight that just so we can see which one I'm referring to. So that's this inequality here. Okay, and it's a hollow circle because we're not including 2 itself. For the second inequality, which is this one, I'm going to draw it on there as well. We're interested in all the values between -1 and 3. 3 I can label around about here, and -1 is somewhere here, and we're just interested in the values that lie between -1 and 3. So it's this region. So our job is to identify which range of values satisfy both regions. Well, it's where we have the 2 lines, okay, where they coincide. The 2 lines coincide in this part. Okay, so that tells me I can now write down my set of solutions. So to satisfy both inequalities, I need the region between, oops, put it in pen mode. We need the region between -1, but not including, and up to 2. It's the most restrictive constraint you can get with the 2 inequalities you've got. Okay, so that's how we do that one. In question 3, we're asked to write both of these as one single. Oops. Let's undo that. Oops. Let me just erase this. Just using the wrong pen. So in question 3, we're asked to write both of these as a single fraction. Obviously, we're going to have to find a common denominator here. And when we're using, when we're working with algebraic fractions, of course, we need to multiply the denominators together to get that. So we've done this in the previous chapter. So we have 1 subtract x and 2 add x. And just to go over the argument again, if I want to find the common denominator, the fraction on the left-hand side, I'm forced to multiply this by 2 plus x, because that's the factor that is missing at the moment in the denominator. Which, if I'm going to find an equivalent fraction, I have to do exactly the same thing to the numerator. Okay, otherwise it won't be an equivalent fraction. So in my numerator, I need to have 2 multiplied by 2 plus x. And you can see if you just cover the 2 plus x in the numerator and denominator, you can see that they will cancel and you will get back to the 2 over 1 plus x that we started with. Okay, now then, on the right hand side, this time we are looking at 2 plus x in the denominator. My common denominator is, of course, 1 subtract x multiplied by 2 plus x. So I'm missing the factor 1 subtract x here. Okay, I have to multiply the 2 plus x by 1 subtract x in order to get this part. So I have to do the same thing to the numerator in order to make sure that this is an equivalent fraction. And it's a subtraction, so it's going to be subtract, and let's write it in again. It's going to be 5 multiplied by 1 subtract x. And now it's just a case of tidying everything up, really. Now, so let's just expand the brackets. So we have 4, add 2x, subtract 5, and then be careful with the double negative, add 5x. And if you like, you can expand the denominator if you want to. So that's going to be 2 plus x minus 2x, so subtract x squared. And then a bit more collecting like terms. So we're going to have a negative 1, add 7x over 2 subtract x squared. And there we have our single fraction. Now over in question 4, we do the opposite, although the skill set is the same. We're going to write this single fraction with a factorized denominator as partial fractions. So the first part of this task is you obviously need to sort of conjure up the knowledge about partial fractions that we covered. What is this identical to in partial fraction terms? Well, we must have something over 3 subtract x and something else over 4 plus x. Now, if we just make a little note about what's going on, this denominator is, of course, a quadratic, so it has an order or a degree of 2. The numerator is a linear expression, and this has a degree of 1. Now, because the degrees are not equal and the fact that the numerator is strictly less than the denominator, this is what we call a proper algebraic fraction. So it's a proper fraction, in other words, which means that our 2 partial fractions must also be proper. Now, to make an algebraic fraction proper, the degree of the numerator has to be less than the degree of the denominator. And here, the degrees are both 1 because they're both linear. So our only option is to have a degree 0. And anything to degree 0, so in other words, x to the power 0, which is just 1, or it could be like 2x to the power 0. We don't know what the answer is. That is, of course, 2. But either way, you're just going to get a constant. So let's just jot that down. So we're going to have constants in the numerator and the denominator. We don't know what they are, so we just call them a and b usually. All right, now our task is now to reconstruct the left-hand side using what we know on the right-hand side. So we have to combine these 2 fractions in the same way as what we did in question 3. All right, so our common denominator, this is an identity, of course, is going to be the 2 linear expressions multiplied together. And then I won't go through the idea again, but we have to find equivalent fractions for each of these. So we have a, and the missing factor is, of course, 4 plus x. So that's going to go in there. Add b. B over here. Okay, the missing factor in the denominator is, of course, 3 subtract x. So we have to multiply it by that. I know some of you say cross multiplying, but I don't really like using that expression. It can be misleading. All right, and all of this is, of course, identical to 3x subtract 2 over 3 subtract x over 4 plus x. So I'll just dispense with this inequality here. Now, we can see that the denominators are, of course, identical. There's no reason to compare those anymore. And it's up to you how we proceed. So if we equate coefficients in the numerator, we should be able to get our A and B. So let's multiply out. So looking at the numerator, or looking at the numerators, we're going to have 4A plus AX multiplying out plus 3B minus BX, or subtract BX, is absolutely identical to 3x subtract 2. Now let's equate coefficients. Now, if we compare the x's, first of all, so on the left-hand side, we have got A amount of x here, subtract B amount of x there. So A subtract B must be equal to 3 on the right-hand side. Okay, and now we can compare the constants. So I'll just use C's for that. So if we compare the constants, we're going to have 4A. I'll do it in a different color so we can see. So 4A add 3B. Yeah, I'm just recording. Sorry, it's all right. Oh, I won't be a minute. Oh. Right, okay, let's carry on. So that's 4A add 3B is equal to -2 on the right-hand side. All right, so this is going to be 1. We'll call this 2. Now we have to figure out a way of solving the simultaneous equations. Now, one way to do it would be to multiply the first equation by 3 or 4, or multiply it by 3. So we'll just rewrite it out over here. So this is going to be 3A subtract 3B is equal to 9. And in the second one, 4A add 3B is equal to -2. Okay, I'm just rewriting them as 1 and 2. They're the same equations. They're still exactly in the same proportion. And what can we do here? Well, because we've multiplied by 3, it'd be a good idea to add them together, like so. This will give us 7A. Hopefully the B's will cancel, and they do, is equal to 7. So A must equal 1. So therefore A equals 1. And let's substitute our result in let's say the first version of 1 that we used. So in other words, A subtract B equals 3. So if I put A into that, we're going to get 1 subtract B equals 3. So in other words, B is going to equal -2. Okay, and we're finished. So our one and only worked example for this lesson involves using the work we've done on partial fractions combined with the latest work we've done on the binomial expansion. And we're hoping to show that the expansion for the algebraic fraction given in part A actually expands to this for the first 4 terms. Right, now to get us started, it's been broken up into 3 parts. The third part, of course, part C, is relatively trivial. We've been through that a few times. But the first part, we're going to have to recall what we did in chapter 1, which is to express an algebraic fraction in partial fractions. So I'm just going to make a note of this. So just recall from previous work we've done, we can set up an identity with an unknown constant a over 2 subtract x in the denominator. That's one of the factors. And then add another unknown constant, we'll call it b, over the second factor, which is 1 plus x. And you can do this with any fraction where you can factorize the denominator. So what we're going to do now is the process states that we need to find out what the constants a and b actually are. And we can do this by recombining what we have on the right-hand side and form what we want to get on the left-hand side. So we need to show that there are some constants a and b that will give us the 4 plus 10x. So the way to do this is we're going to find an equivalent pair of fractions. So our common denominator is, of course, what we started off with, which is 2 subtract x and 1 plus x. So I'll write those in. 2 subtract x multiplied by 1 add x. And to get the partial fractions made into equivalent fractions, of course, we have 2 subtract x here. Now, it's missing a factor of 1 plus x, which means that I have to multiply my a by 1 plus x. So I'm going to do that now. You've done this several times now. So a multiplied by 1 plus x. And remember, if you cover up the 1 plus x in the numerator and the denominator, it cancels down to the a over 2 subtract x. All right, and then same idea for b. The denominator in b, as it stands in our partial fraction, is missing a factor of 2 subtract x, which is featured over here. So we need to multiply the numerator by 2 subtract x. So let's do that. Okay, and now we just tidy everything up. Now I'm going to set up an inequality, sorry, not an inequality. I'm going to set up an identity, which is going to give us 2 possible options. We can either equate coefficients or we can use substitution, but we'll get onto that in a minute. So my identity is going to be, well, we've set it up using 2 pairs of identity signs there. So all of this over here must be identical to all of this over here. Okay, because we have the identity signs in the middle. So let's expand and simplify and set up our identity. So our identity is going to read a multiplied by 1 plus x. We'll expand and simplify in the next step. Add b multiplied by 2 subtract x must be identical to 4 add 10x. Because the denominators are trivial, we can dispense with them now. We know they're identical. They are just the same. So let's expand. So a add ax plus 2b subtract bx is absolutely identical to 4 add 10x. Great. Now, let's equate coefficients. So I'll just make a note of what we're going to do now. You don't have to. You could have used a substitution in the previous step, but I'm going to equate coefficients. Just make a note of that. So first of all, let's look at the x's. Now, if I collect all the x coefficients together, well, we've got plus a subtract b, and that must equal plus 10. So we can write down an equation. So my first equation is going to be a subtract b is equal to 10. Okay, good. And then let's compare the constants now. So, oops, let's undo that. So for the constant term, I'll just call that C's, constants. What do we have? Well, it's whatever's left. So we have A plus 2B. So we'll put that in. A add to 2B must equal 4. All right, so we have two equations. We'll call that equation 1. We'll call that equation 2. And we just solve them simultaneously. Choose whichever method you like the best, substitution, addition, subtraction, whatever it is. I think I'm going to subtract equation 1 from equation 2. So 2 subtract 1, that's going to give me the following. So the A's will cancel, and then I'm going to get 3B is equal to negative 6, which implies that B is equal to negative 2. Okay, so just check that. So equation 2 subtract equation 1. The 2B subtract a negative B is obviously 3B, and 4 subtract 10 is negative 6. Okay, so let's now sub that in. Sub B equals negative 2 in either equation, doesn't matter, into equation 1. So therefore, A subtract negative 2 is equal to 10. In other words, therefore, A plus 2 equals 10. Therefore, A equals 8. So we now have our partial fractions. So let's just write them out explicitly. Obviously, you've got a lot more space than I have. I'm just doing this for clarity so you can see the question next to the solution. But you can make notes on this. This is completely up to you. They're your notes. It's your revision document. So what I now know is that all of this is now the same as. Now, please, when you're doing this, make sure you get the letters the right way around. So it's A over 2 subtract x. So that's going to be 8 over 2 subtract x for the first partial fraction. And then we have negative 2 for B over here. Okay, so that's going to be subtract 2 over 1 plus x. Okay, so we have part A done. So for part B, we need to build up to this expansion. Now, there's going to be quite a lot of work involved in this. So let's just see what we've got. So now, obviously, if we're going to do an expansion, we need to rewrite our partial fractions. So we have 8. Now, it's 8 over 2 subtract x. So what I need to do now is write the 2 subtract x as a negative power. So it's 2 subtract x to the power negative 1 multiplied by 8. And then for the second partial fraction, so it's going to be a subtraction, subtract 2, and then we have 1 plus x to the power negative 1. Right. Now, this is where we've got to bring in our binomial expansion work that we've just done. Now, you might be able to tell, just sort of jumping a few steps ahead, well, in our heads, of course. This expansion here is relatively straightforward. It's one we've done before when we introduced the topic. We don't have anything to worry about in terms of the constant term at the front because it's just 1. Here it is. So we don't need to do any clever factorization or anything like that. It's a straightforward expansion. Just bear in mind that it's going to be multiplied by negative 2. The expansion over here, however, is going to need a bit of work. So here I'm going to do some side work, of course. I'm going to split the question now into looking at 2 subtract x to the negative 1 and 1 plus x to the negative 1, and then we'll combine our results. Okay, so we need to call these brackets something so we know what we're talking about. So I'm going to refer to the first bracket here as bracket A with a big green circle, and we'll call this bracket B. So let's work on A first of all. So I'm just going to have to erase some of this working out, and then we'll get cracking with the expansion. So for part A, or bracket A, which we're going to talk about first, let's first of all consider the linear expression 2 subtract x. So 2 subtract x, I can of course rewrite this. I use my factorization. So I can write this as 2, and then obviously the bracket comes in and we get the constant 1, and then we subtract x over 2, like that. And again, if you want to just check it, just multiply that right-hand side out quickly so you can see that they are actually the same. Now we can consider what happens when we raise both of these to the power -1. So to the power -1, we have 2 subtract x to the power -1 is of course equal to, I'm just going to write it out first, so 2 multiplied by 1 subtract x over 2, close the bracket, and let's put some big square brackets around this, to the power -1. All right, now we can separate out the 2 factors and raise them both separately to the power -1. So this is of course equal to 2 to the power -1 multiplied by 1 subtract x over 2 to the power -1. And we have one step, we can just tidy this up. 2 to the power -1 is of course just 1/2 multiplied by 1 subtract x over 2 to the power -1. So there we have it. Now, let's do the expansion. So I'm just going to partition the board a little bit. Let's just rewrite this. So we're going to perform the expansion. This is for A only. 1/2 multiplied by 1 subtract x over 2 to the power -1. And as is customary, what I recommend you do, write down what your n is and write down what your b is before we do anything else. So b is -x over 2, and we are going to refer to these 2 values from now on. We do not go back to any of this stuff over here on the left. Okay, it will just mislead you. You'll be putting in the wrong values. So stick to this and just carry out the expansion. Right, so we're going to have 1/2 now, big square brackets. And we need up to the x cubed term. Okay, it says that in the question explicitly, so that's what we've got to do. So we're going to have 1 add NB plus n multiplied by n minus 1 over 2 factorial multiplied by b squared. Okay, plus n multiplied by n subtract 1 multiplied by n subtract 2 over 3 factorial multiplied by b cubed. Oops, just made a mistake there. Should be 2. Okay, just make sure you check what you're doing. Plus dot dot dots, close your square brackets. Now then, let's just do a little bit more work on this. So this is going to be 1/2 multiplied by 1. Now we've got a double negative in there, so that's going to be plus x over 2. Okay, and then we'll just tidy up these brackets a little bit. Plus -1 multiplied by -2 over 2 factorial, which is 2, and then square the bracket. So that's going to be x squared. Negative x times itself is, of course, x squared over 4. Then add -1 multiplied by -2 multiplied by -3 over 3 factorial, which is 6. And then multiply all that by -x over 2 cubed. So that's going to be -x cubed because there'll be 3 negatives creeping into that if you expand it all out. And then 2 cubed is, of course, 8. Close your bracket and then add some more terms, but they're not necessary today. So this is going to equal 1/2. Okay, then we have 1 add x over 2. Now we have lots of nice cancellation here. So we've got the 2's will cancel and the negatives will make a positive. So that's good. So it looks like we've got all cancel basically. So it's going to be add x squared over 4. So it looks like all these are going to be positive. And then on the final term, we have 4 negative signs. That's going to be a positive, definitely, and it fits in with the pattern, which is a good sign again. All right, and then we have lots of cancellation. So let's just have a look at this. Well, the 2 and the 3 will cancel with the 6. So we're left with a rather nice expansion here. So this is going to be x cubed over 8 plus some more terms. And the final step, let's multiply all this by 1/2. So this is going to give us 1/2 plus x over 4 plus x cubed, x squared over 8 plus x cubed over 16 plus some more terms if needed. All right, so let's just summarize where we're up to. So we've just discovered the expansion 2 subtract x to the power -1, which is given here in the top right, I should say. And what we now need to, this is what we've just worked on. And then also on the left-hand side over here, I've just rewritten the expansion that we need to carry out. So the part A, or bracket A, we've done. Now we need to look at bracket B. Now, in order to do that, this is a lot more straightforward. So let's get to it. We'll just do it again. I know we've done this one before, but it's good revision. So for bracket B, and remember you've got a full page to do this. So just continue from this point onwards. I was just trying to summarize it because I'm limited in space on the screen. Now, for the 1 plus x to -1, we don't need to do any factorization out of the bracket. We can just go straight to it. Just write down what your n and your b are. So n equals -1 and b is simply x. And you can go straight into the expansion. So this is going to be equal to 1 plus nb, which is -1 multiplied by x, plus n multiplied by n subtract 1 over 2 factorial multiplied by b squared. So I can just literally put x squared in there, and then add n multiplied by n subtract 1 multiplied by n subtract 2 over 3 factorial, and then b cubed. So in other words, x cubed plus some other terms. Tidy up. So this is going to be 1 subtract x with the negative and positive term. Then again, I'm not going to try and do too much, even though I've done this lots of times now. I'm not cutting any corners. There is absolutely no point risking losing any marks on this. Just put in all the steps, take great care with the signs, and you'll be absolutely fine. So n n minus 1, n minus 2, 3 factorial is 6, and that's x cubed, plus some more terms. So we can finish this now. So this is going to be 1 subtract x. Let's just go through the cancellation. So let's have a look. We've got -2 and 2. Well, that's going to cancel to be -1. And because it's a double negative, it's going to be an addition there. So this is going to be plus x squared. We have this alternating sign pattern. So I'm going to predict the next term is going to be negative, which of course it is. We've got 3 negatives there. And then for the cancellation, we have the 2 and the 3 cancel with the 6 in the denominator. So that's going to be 3 negatives and then 1. So it's going to be -1. And there we go. And that's going to be x cubed. So negative x cubed. Okay, which was how this process was introduced several lessons ago, plus some other terms. So up in the top right, I'm just going to summarize this. We've just worked out expansion for b. So we now know that 1 plus x to the power -1 is of course equal to 1 subtract x, add x squared, subtract x cubed, and then add some more terms if necessary. So all the expansions all finished. Now we can go back to the expression we have over on the top left, over here. And if we substitute everything in, we're hoping, fingers crossed, that we are going to get this. So let's do this. So just to finish part B off, so this is where you cross your fingers and hope this is all worked out. You've not made any mistakes. So finally, okay, so let's write out the step again. So we know that 8 multiplied by 2 subtract x to the power -1, subtract 2 multiplied by 1 add x to the power -1 is equal to 8 multiplied by, let's put in what we discovered earlier. So what we discovered part for A, the bracket A, it's going to be 1/2 plus x over 4 plus x squared over 8 plus x cubed over 16. Close that bracket. Okay, I'm just going to erase some of this just so we don't get mixed up. I've done all this now. Okay. Then we're going to subtract what we've just discovered. Oops, still an eraser there. So we're going to subtract 2 lots of the 1 plus x to -1. Now that is more straightforward, isn't it? So it's going to be 1 subtract x, add x squared, subtract x cubed. Okay. Notice that I'm not putting the plus ... here. It's not specified in the final expression. Okay, it's just up to and including the x cubed term. Now then, let's just expand this. So I'm just going to partition the board again. So this is going to equal 8 multiplied by 1/2, which is of course 4. 8 multiplied by x over 4, which is of course 2x. And then 8 over 8, that's going to cancel. So that's going to be plus plus x squared. And then 8 over 16 is 1/2. So that's going to be x cubed over 2. That's multiplying the first bracket by 8. So that bit's done. Okay. Now we're going to move on to the second bracket. So we're going to multiply all of this by the -2. So I might as well change color for this. So it's going to be subtract 2. Be careful with your signs here. We have -2 multiplied by -x. So that's add 2x. Continue on. So that's going to be -2x squared. And then 2 negatives again, add 2x cubed. Now, this is the final step. Let's collect like terms. So, let's be careful with this. So, first of all, we have 4, subtract 2. So that's going to be 2, which checks out with this. So that's good news. So I can write 2 as my first term. Next up, we have the x's. So we have plus 2x here. Add 2x here. So that's going to give us the 4x that we need here. Brilliant. So it's going all right so far. Fingers crossed. So I'll just put that in. So add 4x. Next up, let's have a look at the x squareds. So we have plus x squared, subtract 2x squared. So that's going to be negative x squared. Yes, that matches here. It's exciting, isn't it? So negative x squared, is that what I said? Yes, it is. Okay, and then finally, we have the x cubed. Let's change colour again. Which colour have I not used? Let's do purple. So this one, we've got a half x cubed, add 2x cubed. Now, that's essentially 2.5 x cubed, which we can write as 5 over 2 x cubed, which is what we have here. Fantastic. So it looks like it's all checked out. So plus 5 over 2 x cubed. Now that is a mammoth task to get all that done. A lot can go wrong, but it's doable. Okay, they are marks where you don't have to think too much. It's just a case of following through the procedures. Now, going on to part C now, we have to state the range of validity for which the expansion is valid. Okay, well, let's just do some erasing and then we'll get on to that. All right, so for part C, state the range of values. Well, we have 2 expansions, of course. The first expansion was bracket A, and you'll have this on your screen, but you'll remember, of course, that it's all about the B value, isn't it? Okay, so let's just jot down what the B value was for bracket A. So it will be, I'm just looking at it now, it will be negative x over 2. That was your B value. And for bracket B, which was the 1 plus x, your B value in this case would just simply be x. Now, we'll start with the B bracket because that's the easiest one to state. So the range of validity okay, we can just say, well, yes, we know it's between negative 1 and 1 for the B values. All right, so it would simply just be all x values between negative 1 and 1, all real x values. So that's for bracket B. Now for bracket A, it's slightly different. So the range of validity so once again, it's all the B values between negative 1 and 1. Now in this case, if we sub in the B value, so of course it's x over 2 this time, sandwiched between negative 1 and 1. We have to multiply by 2. So it's going to be this. So we have for each bracket in this expression, each bracket that was expanded to the power negative 1, we have 2 range of validities that are sort of conflict each other. So remember what we talked about in the warm-up. You have to be able to substitute x values into the whole thing. Okay, they've got to be valid here, and they've got to be valid here if they're to be valid for the whole expansion. So you have to take the strictest rate, the most limited value the most limited range of x values that you possibly can, in order to ensure that the expansion is valid within those parameters. I hope that makes sense. If you're not convinced, another way to do it is just to quickly draw a graph an inequality graph. So I'll do that. So I don't think I was very clear then. I put 0 in the middle. These are x values. We'll put -1 and 1 on there. Now, for bracket B, your range of validity covered the values not including -1 and 1. Right, so that was for bracket B. Now, for bracket A, it was a different story. It's between -2 and 2. So it's a wider range. But because these feature in the same expansion, you can only take the values that are applicable to both, which is, of course, where the lines cross over. So the only range of values we can use are the most stringent ones, which is -1 to 1. So just to finish that off, your final answer will be, range of validity will be x values between -1 and 1. And we are finished.